Welcome back, everybody. Today, we're going to be looking into AI video generation. You know those AI image generators everybody's talking about? Well, this is like that, but for video. And getting video right, that's a whole other challenge, especially when it comes to making things move realistically. You set over some research on something called VideoJAM. So let's try to figure out why everybody's making such a big deal about it in the AI world. We'll be looking at excerpts from the actual research paper. And trust me, it's pretty fascinating stuff.
Yeah, it really is. It's amazing how much harder it is to make videos than still images. It's not just what things look like, but how they move through time. That's the element that really seems to trip up most AI models.
Yeah, you're right. And that's exactly what this VideoJAM paper is trying to solve. They even have a name for the problem. Pretty pictures, wonky movement. Basically, a lot of these AI-generated videos, they look amazing, but the movement is, well, a little off. It's like watching a dancer with incredibly realistic detail, but their limbs bend in ways that are physically impossible.
Right, and a lot of that comes down to how most of these AIs are trained. They learn by comparing their output to the original video, pixel by pixel. And while that can make things look pretty realistic, it doesn't really understand the how and why of the movement.
So it's like focusing on the individual pixels doesn't give the AI the full picture of how the movement should actually work.
Exactly. The paper actually shows a few examples of these motion fails. Like, do you remember that one with the jogger? It kept stepping on the same leg over and over
Oh,
again.
yeah. It was like the AI forgot how legs work.
Exactly.
What about the hula hoop? It generated a woman twirling a hula hoop, but instead of going around her waist, it passed straight through her body, like some kind of ghost hoop.
Yeah. And who could forget the spinner that couldn't even rotate properly? It was like it had no idea about the physics of how a spinner should move.
It's like these AIs are missing some kind of fundamental understanding of motion, even for movements they've seen a ton of times in the data they learned from. So how does VideoJAM try to solve this? How do they fix this wonky movement?
Well, VideoJAM tries to do it a little differently. It tries to teach the AI to learn both how things look and how they move. So instead of just looking at what things look like, it also has to think about how they move at the same time.
Interesting. And they do all this by just adding 2 extra layers to the AI model.
Yep, that's all it takes.
That's really clever. So what do these new layers actually do?
Well, one of the layers combines the information from the video with information about the motion. And then the other layer uses this combined data to try to predict how things will move.
So it's almost like giving the AI a second set of eyes that are only focused on movement.
That's a good way to put it.
It's kind of like how athletes train. They don't just focus on building muscle. They work on agility and coordination, too. It's about integrating different aspects of performance.
Exactly. And that's what VideoJAM is trying to do for AI video generation. And to do that, they also have to change the data they use to train the AI. So instead of just using raw video frames, they also use something called optical flow data.
Okay, optical flow data. That sounds complicated. What exactly is that?
Well, I imagine like a heat map. That shows how each pixel in the video is moving. So it basically gives the AI a much better idea of the motion that's happening.
So like showing the direction and speed of each pixel.
Right.
So basically, it is like giving the AI a second set of eyes, but this time these eyes are focused just on movement.
Exactly. And by training on both the video frames and this optical flow data, it forces the AI to really pay attention to how things are moving.
So now the AI has a much better understanding of both what things look like and how they move.
But wait, there's more to it, right? There's this thing called inner guidance.
Yes,
And this is where things get really interesting.
it is.
So what is this inner guidance?
Well, it's basically like having a coach inside the AI, telling it how to move better. As the AI is generating each frame of the video, inner guidance is kind of predicting the motion that should be happening. And it uses this prediction to guide the video generation process towards more realistic movement. I see. So it's not just watching the motion, it's actively using its prediction to try and correct things as it goes.
That's a good way to think about it.
It's like a built-in choreographer, making sure the dancer doesn't, break their spine or something.
All right.
So we've got all this information about appearance and motion from that joint training we talked about, and then we have an inner guidance, acting as the AI's coach. But the question is, does it actually work? Does VideoJAM actually make the movements smoother and more realistic?
The results are really promising. In terms of motion quality, it actually beats a lot of other models, even some of those super secret ones the big tech companies are working on.
Hold on. It's better than the top secret AI models. That's a pretty big claim. How did they even compare them?
They did a bunch of tests using several different benchmarks, including one they developed themselves called VideoJAM Bench.
VideoJAM bench. Sounds intense. What's so special about this benchmark?
Well, they designed it specifically to test those tricky motion scenarios, the ones that usually cause problems for AIs. So they had prompts for basic things like running and walking, but also some more complex movements like gymnastics and stuff.
So they were really trying to see what this AI could handle.
Right. They also included prompts that needed some understanding of physics, like objects colliding or interacting, to see if VideoJAM could generate movements that actually made sense.
Okay, so they put VideoJAMs through the ringer. Did it pass the test?
It did. In fact, it consistently scored higher than the other models on all the metrics they used to measure motion quality. It wasn't just that it looked better, the data showed that the motion was more realistic and believable.
So it wasn't just subjective.
No,
Wow. So the AI can really move.
it can.
They didn't just rely on data, though, did they?
No, they didn't. They also had actual humans watch the videos made with VideoJAM and videos made with other models.
Yeah.
And they asked them to pick which ones looked more realistic.
What happened?
VideoJAM won.
No.
Yeah, people consistently said that the videos made with VideoJAM had the most natural and believable motion.
That's impressive. It's one thing to have the numbers, but it's another thing entirely to have real people look at it and say, yeah, that looks real.
Exact.
Did they do anything else to try and figure out what makes VideoJAM so good?
They did. They did something called an ablation study.
An ablation study? What's that?
Basically, they took VideoJAM apart piece by piece to see which parts were really important, like a game of Jenga.
I see.
So if they removed something, and the motion quality got a lot worse, they knew that part was important.
Interesting.
What they found was all the key parts of VideoJAM, the joint training, the optical flow data, the inner guidance, they were all essential. If they removed any of them, the motion quality got noticeably worse.
So it's the combination of all those things working together that makes VideoJAM so effective.
That's right.
But I'm just thinking, if they're using optical flow data and that data is wrong, wouldn't that mess up the AI?
That's a great point, and it brings up an important issue. Just like with us humans, the quality of the AI's output depends on the quality of the data it learns from.
So if the optical flow data is bad, the AI might learn to move in unrealistic ways.
Exactly.
So there's still a lot of work to do there. But even with that in mind, I think the success of VideoJAM points to something much bigger. It's not just about making cooler videos.
Right. You're absolutely right. I think it shows us that to make truly realistic AI, we need to go beyond just recognizing patterns. We need to understand how things move, how they interact, how they change over time.
So what you're saying is, for AI to really get us to make stuff that's indistinguishable from the real thing, it needs to be able to do more than just look at pictures.
Yeah,
It needs to understand movement.
exactly.
Wow. So it's like AI is finally learning how to move,
That's a great way to put it.
and VideoJAM is showing us what's possible.
I think so.
So what kind of things could this lead to? I mean, we've already talked about CGI and animation, but what else?
Oh, that's so much potential here. Imagine self-driving cars that can navigate through traffic more safely and smoothly because they understand how other cars move.
Right.
Or robots that can help with surgery, or physical therapy, because they understand how the human body moves.
It's like we're giving AI a whole new sense,
Yeah,
one that lets them experience the world in a way that's closer to how we experience it.
and like with any new sense, it takes time to learn how to use it properly, but VideoJAM shows that we're making progress.
That's really cool. So this isn't just about making better videos. It's about a whole new way for AI to understand the world.
I agree.
And that could change everything.
It could. It really makes you wonder, if we can teach AI to understand motion, what else could we teach it?
Right. Could we teach it about emotions, like how to recognize different facial expressions? Or what about social interactions, how people move and behave in groups?
Those are great questions, and they're things that researchers are already starting to look into.
That's amazing.
If we can figure those things out, it could change so many different fields: robotics, healthcare, education, you name it.
I don't know about you, but I'm starting to see movement everywhere now. It's like there's this whole other layer of information that I never noticed before.
I know what you mean. It's like VideoJAM has given us a new way to see the world.
Well, this has been a fascinating deep dive. Thanks for taking us through it.
It was my pleasure.
And to everyone listening, we hope you enjoy this exploration of VideoJAM and the future of AI motion generation. Until next time, keep exploring, keep questioning, and keep diving deep.